That machine didn't exist before this job. A conventional setup runs $30,000 and it still can't reach this site. So we built our own for $8,500, and here's how. Helical piles are non-negotiable on a slope this steep. The old staircase and landings were failing. Things were moving. There was motion in the hill. The staircase had dropped in one spot, so it wasn't safe to walk up and down it anymore. The smallest conventional pile driver setup needs a mini skid steer to run it. 2 tons of machine on a 30-foot drop? It ain't happening. So the job came down to one question. Can we drive a helical pile without a machine that weighs 2 tons? Turns out we can. So this is the Little Beaver hydraulic unit. It's coupled to an 11 horsepower Honda motor, and this is the part that drives the head unit to drill the holes. This is a torsion bar that connects to the base unit, the hydraulic section, and the head. This is what keeps you from getting flung off the machine and into outer space because of the torque that it creates when you're digging a hole and you hit rocks or roots or obstructions in the hole. This thing locks up and keeps it together. There's 2 pieces. One hooks to the base unit, one hooks up to the head unit, and then they slide together. So when you're drilling a hole straight and you have this unit going like this, you can still move it around and it slides back and forth so you can keep the hole drilling straight. So this is the power head. This is the other side of what drives the auger to turn and to dig your hole. Normally, this head unit has to be attached to our hydraulic unit for it to work. It's incompatible for what we're doing. This is a very steep slope, up to a 70-degree angle. We had to adapt it over to make it work for us. So the Little Beaver was designed to drill a post hole quickly. It has a high-speed head and it's a lower torque, but with the hydraulics, it works better. That wasn't gonna work in this circumstance. I need a high torque, low speed option to be able to drive a helical pile into the ground versus trying to drill an auger bit into the ground just to drill a hole. So as you can see here, this is what was in the ground. Now, whoever built this original landing and staircase set, they just took pressure treated 6x6s and they did direct burial. These are buried up to like 5 feet in the ground. Some of these that we took out of the hillside were already rotten. This hill has a lot of clay in it. So we want to make sure that we get our footings deep enough so that if there's any seismic activity going on, that this whole thing doesn't want to just slide down the hill. So my friend Max at Masscore Helical Piles sent me this driver head, and these are around $4,000 for this driver head. It'll run about 3,500 foot-pounds of torque to get the piles down into the ground. So we had to have this, but then I had to have a way to adapt it to our current driver head. So then I had a local welder fabricator come up with this plate and this torsion accessory right here, because the old torsion bar was right here. This was the old one. Here's the new one that we used, and then we had to have an adapter to adapt to our helical piles that adapted to the driver head. So that ran about $500 to have that section done and welded in and made so that our hydraulics would work. And then this part here hooks up to these holes right here on the helical piles. Now these are smaller helical piles, but they're fine for what we're using for this hillside. The whole idea here is we just want to get them deep enough so that we're into native soil, that there's no obstructions. Now, down the hill where it's 6 feet deep, we're gonna have to put extensions on these things to get them deep. Now, we're 30 feet down the hill. How do we get the hydraulic unit down here to run the driver head? Well, we don't. We actually keep the hydraulic unit up where it's flat, and then I had 50-foot hoses made so that we could come down the hill with our hoses, still leave it hooked up to the machine, and be able to drive this driver head remote from 50 feet away. We have the hydraulic unit, which I got used on eBay for $2,000, which normally is $7,000 new. Then I got the hoses were about $2,000 to have all the fittings and the hoses made and all that stuff. And then the $500 setup for having this done, and then $4,000 for the hydraulic driver head. So that came to about $8,500 to put this together with the parts and pieces that we needed. We Frankensteined our own hydraulic driver for hillsides. All right, so we predetermined where we want our pile to go in. And if it goes smooth, it'll go straight down, but we want to be at least 1.5 inches off this line. And we want to have the edge of the bottom of the pile right at the edge of this hole. So we have a couple inches of play as we drive this down. We don't want to be too close to the string, and we don't want to be too close to the edge of this hole. We've already got a 16-inch head start because of the old footing holes. And then the landing's gonna go back this way. So this is our kingpin, and we're gonna go ahead and set this. Everything else has to be really accurately placed. So now that we have this kind of where we want it, we're gonna lift the driver head on top and run some bolts through here for the driver head to couple to so that we can start our machine and start driving this pile down. There you go. The head for the unit is not light. With the high torque, low speed driver attached and the metal all the steel that's put together on it, one man can do it, but you have to be pretty strong. So a two-man carry is usually essential. If we didn't have the torque bar, it would be a real problem for us. We wouldn't be able to drive these piles without this torsion bar setup that we have. We didn't stake it to the ground because it's on a hill. Wherever it spins and locks in, that's where the torsion bar goes. And it works really good, and that allows us to move this steel back and forth. Initially, we got a good bite into the ground. We knew that we're digging in clay. Clay is really hard to use helical piles in this sort of circumstance. It took about 20 minutes to drive this one pile 4 feet into the ground. It is basically ran to almost refusal, which means the machine is rated for 3,500 foot-pounds of torque. And we were getting to the maximum torque spec that this head will handle. So I went ahead and stopped the machine. The hydraulic fluid's getting hot, the head is getting really hot, and that's just one pile. But we got it to a good depth. I got about to 4 feet deep. You could hear it. Hear the gears start to really slow down and start grinding really hard. Then I know, besides the pressure gauge was at its max as well. I mean, I'm just putting my foot on this whole head, and I know how heavy this head is. This pile is barely moving. It's just, it blows me away once you get a certain amount of the pile in the ground, how stable these become. 35 years in, and I'm still pushing myself to find unique ways to solve difficult problems. This machine costs $8,500, and it solves a problem that a $30,000 machine couldn't touch. And it works well enough that we're gonna finish the project with this machine. Any contractor dealing with a site where conventional equipment can't reach, I suggest trying something like this. This may help somebody out in the future.